students, today we shall discuss the last concept in module 1, that is steering gear mechanisms. So when we are driving automobile, so we need to take a left turn or right turn. So when the turn is being taken out, so what is the exact mechanism that is going to take place, we shall study now. So in figure they have shown the automobile chassis and wheels. We can see that there are four wheels. Mm, in front axle, that wheels turn when we are going to take left or right turn, and the which are pivoted on the points A and B as shown in figure. So the front axles is A and B, and rear axle as shown in figure. The distance is shown as the distance between the wheels is A, and the distance between front and rear axles is B, and the distance between the chassis is C. So these points are fixed to the chassis. The back wheels are placed over the back axle at the two ends of the differential tube. When the vehicle takes a turn, the front wheels along with the respective axles turn about the respective pivoted points. The back wheel remains straight and do not turn. Therefore, the steering is done by means of front wheels only. So when we are going to take a turn, only the front wheels will rotate, and the back wheels it remains as it is. So all the mechanism that is taking place will takes place only with the front wheels when we are taking turn. So we shall see the condition for correct steering. In figure they have marked the points P and I, and the condition for correct steering is that all four wheels must turn about the same instantaneous center. The axis of the inner wheel makes an larger turning angle theta, and the angle phi subtended by the axis of the outer wheel. So when say for example, when the car is taking left turn, the angle turned by the inner wheel, when we are taking left turn, the left side wheel becomes inner wheel and the right side wheel becomes outer wheel. So the angle of the turn of the inner wheel will be theta, and it will be more when compared to the angle turned by the outer wheel phi. And the instantaneous center of both these angles, it lies at a point I, and this point I, it is along the back axle of the automobile car. So from figure, the A is the distance between wheels, and B is the distance between front and rear axle, and C be the distance between the chassis, or the C is the distance between pivot points A and B. So from triangle, we shall take from triangle IAP. So from triangle IAP, cot theta is equal to, so before taking cot theta, we shall take tan theta. So tan theta says that it is the ratio of opposite side to adjacent side. So it is IP by BP. So cot theta is the reversal of tan theta. So we shall reverse, and we will get as BP by IP. Similarly, from triangle IAP, again we shall take the ratio of cot phi. So cot phi or tan phi, tan phi is IP by AP, and the reversal of this is AP by IP. So cot phi is AP by IP, but AP is nothing but it is the sum of BP plus AB. So we shall differentiate this ratio. So if we differentiate, we will get AB by IP plus BP by IP. So from cot theta, the ratio is BP by IP. So we can replace cot theta in place of BP by IP, and in place of AB by IP, we can replace C divided by B, because from figure AB is equal to C and IP is equal to B. So in this ratio, we'll send cot theta to the LHS side. So if I send cot theta to the LHS side, it becomes cot phi minus cot theta is equal to C divided by B. So this is the correct mechanism condition for the steering of a vehicle or a car when it is taking left turn or right turn. So here in this condition we have only discussed for left turn. So same principles applies for the vehicle which is taking right turn. So if the vehicle is taking right turn, all the same principles applies. So only that the point I and P, it is on left side. When the vehicle is taking on right turn, it will come towards the right side. So this is the exact condition for steering, and if this condition is satisfied, then there will not be any skidding of the wheels while the vehicle is taking a turn. So when the vehicle takes a turn, there will not be any skidding of the wheels. So next, the important concept we shall discuss is Ackermann steering gear mechanism. So this is the continuation of this mechanism itself. So we can see from the figure, AC is front axle and EF is rear axle, and we can see that there is a new link called MN. So AC, CN, MN and MA are the four links, and these form a 4-bar mechanism. So AB and CD are stub axles but integral part of AM and CN, such that BAM and DCN are bell crank levers pivoted at point A and C. So AB is the link fixed to the left wheel, and AC is the link fixed or axle fixed to the right side tire. So A, M and C are the 4-bar mechanism. So for steering a vehicle on right side, if link NM is moved towards left hand, with the result that the link CN turns clockwise. So when I am interested in taking a right turn, the link NM has to be moved towards left side or left hand side, so that the link CN turns clockwise. So when the link CN turns clockwise, the vehicle, the front tires, it turns towards the right side, and the vehicle can be taken to the right turn. So thus the angle theta is increased, and that the other side it is decreased. So angle theta will be for right tire, and for left tire the angle will be phi. And as we have learned that the angle theta will be more when compared to the angle phi. So from the arrangement of links, it is clear that CN or inner wheel will turn by an angle theta, which is more than that angle turned by the outer wheel or the link AM. So to satisfy the basic equation of steering, we have to arrive at cot phi minus cot theta is equal to A divided by L. So as per the correct steering mechanism, if the ratio of cot phi minus cot theta is equal to A by L is satisfied, then it will be proper steering. So from figure you can see that when we are taking a right turn, the link MN is moved towards left side, and due to the movement of link MN towards left side, the axle CD, it rotates by an angle theta, and the axle AB, it rotates by an angle phi. So the from figure it is clearly that understood that the angle theta is more than the angle phi. So when the vehicle is taking right turn, the angle theta or the right side wheel should tilt by more angle when compared to the left side angle. Thus for different values of theta, the corresponding values of phi and cot phi minus cot theta are tabulated. For approximately correct steering, the value of A by L should be between 0.4 to 0.5. So from figure you can see that the value of A divided by L. So this is fixed. When the chassis is being manufactured, the value of A divided by L is fixed. So the only variables are theta and phi. That is, when the vehicle's wheels are taking right turn or left turn, the values of theta and phi, it will change. So as a matter of fact, the position for correct steering is only an arbitrary condition. So in Ackermann steering, for keeping the value of angle theta on lower side, the instantaneous center of front wheels does not lie on the line of axis of rear wheels as shown in figure. So the instantaneous center, or the point which bisects the both the points angle A and C, it will not remain on the rear axial line. So it will be away from the rear axle by distance 0.3 0.3 L. So in this Ackermann steering mechanism, it will not coincide with the rear axis. It will be at a distance of 0.3 L. So in figure we can clearly see. But in case of the condition of correct steering mechanism, we saw that the point I, it was in line with the rear axle. But usually the point I, it will not lie on the rear axis, but it will be at some distance 0.3 L. So if this condition is satisfied, then the steering will be proper and there will not be any skidding taking place in the vehicle. So this completes the module 1, and in next videos we shall start from module 2.